want to go ahead and graph piecewise functions. Now, we had looked at absolute value earlier. Now, an absolute value can be written as a piecewise function. A piecewise function basically has two or more expressions over here. And when you use the top one, it's determined by what types of numbers you're putting in. And when you use the bottom one, it's determined by what types of numbers you're putting in. This one here says if you plug in anything greater than or equal to 0, you just get out that number. Well, we remember with absolute value, if we plugged in a positive number here, absolute value did nothing. And that's really what it's saying. Down below here, it's saying if you try any number that's less than 0, meaning a negative number, it says we get out the opposite of that. And that matches up with what we had said before. If you plug in a negative, you get out the opposite of that because absolute value makes it positive. And the opposite of a negative is positive. This is an example of a piecewise function. Now, to begin in graphing piecewise, I want you to graph y equals 2x plus 1 and y equals negative 3. Now, y equals negative 3 means no matter what you plug in, you always get out negative 3. So that's just a horizontal line at a height of negative 3. This one here, our y-intercept is 1, our slope is 2, so we start out at 1, go up 2 over 1, up 2 over 1, and we graph our line. Now you might be wondering why I had you do that. Well, we're going to look at our absolute or our piecewise function right here. We have this piecewise function. It says we want to use 2x plus 1 whenever we have something greater than or equal to negative 1. And we have negative 3 as our output whenever we try something to the left of negative 1. So all I did was just draw a vertical line here, a dotted line at negative 1, because that's where we switch from one rule to the other rule. As we look here, it says 2x plus 1. We know that that's the red line. It says it only exists when we're greater than or equal to negative 1. So here's our negative 1, greater than or equal to negative 1. That's to the right or to the left. Well, numbers to the right of negative 1 are greater than. So this line right here only exists to the right of that green dotted line. So I'm going to put that in here. Now, we do need to make one adjustment here. It goes this way here forever, but it only comes back this way to the line and stops. So I need to make an adjustment. I initially had an arrow here, so I need to adjust that so that I don't have an arrow, and then I have a filled in circle because it's greater than or equal to. Now, the bottom one, y equals negative 3, is our horizontal blue line. And it says we only exist when we're to the left of negative 1. So this part over here does not exist. So I'm going to take that and move it back so I'm just to the left of negative 1. Now, once again, I need to adjust this right here where I'm at negative 1. That is not an arrow going on forever. That is an open circle. So I need to make a couple of adjustments here. So just, okay, there I have my open circle, which means I'm not actually including it. There's no equal to. If it has an equal to here, it's something extra with my inequality, so then I got to fill it in. If there's no equal to, it's not including it, so it's an open circle. Now, this green dotted line is not technically part of it. I just put it there to help you see when we switch from one rule to the other rule. So I'm going to get rid of that. So my final graph ends up looking like this.